Hey everyone! So if you're building with tools like AutoGen or Semantic Kernel, you are right there on the cutting edge of AI. But you've probably hit a wall at some point, right? A point where a fluent chatbot just doesn't cut it anymore. And it raises this really critical question for all of us in this space. What's next? What comes after large language models?
Okay, so to make this super simple, we're going to stick to one core idea for this entire explainer. Think of a large language model, an LLM, as a super fluent, charismatic speaker. It can talk about pretty much anything. Now contrast that with a large reasoning model, an LRM. This isn't a speaker, it's an analytical problem solver. It doesn't just talk, it thinks.
I mean, we all know what LLMs are amazing at, right? Spitting out human-like text, summarizing articles, powering our chatbots. They're fantastic. But the moment you ask them to handle a really complex, multi-step problem that needs deep logic, well, that's where they can start to struggle a bit. And that's the exact friction point we're going to dive into.
So what is a large reasoning model? Exactly. Well, it's a class of AI that's been specifically trained to reason. Its whole purpose is to break down complex problems, maintain logical consistency, weigh different options, and then at the end of the day, make a decision. We're talking about an architecture built from the ground up for deep analysis, not just for a nice chat.
All right, let's do this. Let's put them head to head. This is where the differences really pop. We're going to compare our fluent speaker, the LLM, directly against our analytical problem solver, the LRM. Okay, here it is, the highest level distinction you need to know. For talking and writing, you use an LLM. For reasoning and deciding, you need an LRM. It's truly the most important takeaway: communication versus cognition. Now, this is where it gets really interesting, when we dig into the details. Just look at multi-step logic and planning. Kind of weak for an LLM, but a core strength for an LRM. And check this out, agent workflows. For an LLM, it's something you can kind of bolt on. For an LRM, it's a native capability. That means it was designed from day one to manage complex tasks, not just to answer prompts. So this all sounds cool in theory, but where you actually use these things? Let's take a look at the real-world spots where this analytical power becomes a total game changer.
Here are the top 5 domains where they just shine. First, agentic AI systems, where you have multiple AIs all working together. Second, enterprise decision engines, for things like approving a loan. Third, deep reasoning over really complex code bases. Fourth, a much smarter kind of RAG that doesn't just retrieve info, it reasons about it. And finally, automating those tricky business workflows. Let's make this real. Imagine a DevOps pipeline fails. An LLM might give you a pretty good summary of the error log. Helpful, but yeah. An LRM follows a logical process. It detects the failure, it analyzes the logs, it compares the problem to things that have happened in the past, it decides on the best fix, and then it actually executes it. That's true reasoning in action, not just matching patterns. Or think about HR. An LLM can pull keywords from a resume, sure. An LRM, though, can compare a whole stack of candidates against a super complex job description, figure out conflicting information, rank them logically, and, here's the most important part, explain why it made those rankings. That explainability is absolute gold for business application. So you're probably wondering, how is this even possible? What's going on under the hood that gives an LLM these analytical superpowers? Let's get into the secret sauce that really separates it from your standard language model.
The key, and this is the whole thing, is the training data. LLMs aren't just trained on all the text on the internet. No, they are explicitly trained on massive data sets of math problems, logic puzzles, planning challenges, and causal reasoning. And it's this specialized diet that makes them so robust and leads to way fewer hallucinations when you give them a complex logical task.
And for all of you using frameworks like AutoGen, this is huge. An LRM isn't just given tools, it manages them. It can decide when to call a function, which specialized agent is the best fit for a subtask, and, critically, it knows when the job is actually done. It's not just a worker, it's an intelligent orchestrator. Another massive practical advantage is the output. Instead of just getting a paragraph of text back, an LLM can give you structured, reliable data. Think a JSON object, a step-by-step execution plan, or a full-on decision tree. These are outputs you can plug directly into other enterprise software, which makes them incredibly powerful for automation.
Okay, so with all this info, how do you actually decide which AI model to use? Think of it like you're choosing the right teammate for a specific job. You wouldn't ask your star salesperson to write your code, and you wouldn't ask your lead engineer to go close a deal, right? This brings up a really important point.
LLMs are incredibly powerful, but let's be honest, they're also computationally heavier and more expensive to run. So when is it just better to stick with a good old-fashioned LLM?
The answer is actually pretty simple. Use an LLM for tasks that are really just about language. Things like simple Q&A, customer service chatbots, summarizing articles, or generating some marketing copy. For these, an LLM is total overkill. You bring in the analytical problem solver only when the problem truly demands reason.
If you take only one thing away from this whole explainer, let it be this right here. This is the simple rule of thumb. If your AI needs to perform an action, to decide, to plan, to compare, or to explain its logic, you need an LRM. If it just needs to communicate, to talk or write, an LLM is the right tool for the job.
So I'll leave you with this question. Think about the project you're working on right now, or maybe the one you're just dreaming up. Does it need a fluent speaker, or does it need an analytical problem solver? Now that you know the difference, which teammate are you going to choose?